Hi there. The main aim of this workshop is the Year 6 learning in maths, or the main learning in maths, the 4 operations predominantly. So we'll start with addition. Children need to have an understanding of what addition is and what it looks like in real life. They need to have knowledge of the mathematical language associated with addition, such as sum or number bonds to 10, number bonds to 20, because they will need them for some of the methods. They also need to learn the column addition, so because they will be adding 3 and 2-digit numbers, but also 4 to 5-digit numbers. For example, if they are to be adding 365 and 571, there is a demonstration. They write them in a column, making sure that units are under units, tens under tens, and hundreds under hundreds, like this. And then they add them together. 1 plus 5 is 6, 7 add 6 is 13. Once they've done, they've recorded the 3, they carry the 1 over, and then once they've added 5 and 3, they add the 1 to make 9. Similarly, if they're adding decimals, it's very important for them to align the numbers correctly, making sure that when they're recording the numbers using the column addition, the decimal points are one under the other, and that way, in this particular case, 5 and 7 will be in the same column, as well as 2 and 8 and 8 and 9. Subtraction, obviously, another main topic. Again, children need to know language such as difference. What is the difference between these two numbers? We also use column subtraction, similar to column addition. They need to remember that they can't, if they are subtracting 6 from a 0, they will need to exchange, move on to the bigger column and exchange from there. They also need to be able to use subtraction in real life questions. We often use word problems. One example would be subtracting 8,000 from 12,000. Children would either use the column method here, or if they know that 4,000 add 8,000 is 12,000, they can easily work that out. If they know their number bonds, it becomes a lot easier. And another example is 849 take away 230. Again, aligning the digits correctly is very important. 9 take away 0 is 9, 4 take away 3 is 1, 8 take away 2 is 6. Another question where they're subtracting a 3-digit number from a 4-digit number. Now here they will need to be exchanging. So 8 is bigger than the 1 here, so we can't take away 8 from 1, so we'll need to exchange. Which means that we are borrowing, so to speak, from the 2. We're borrowing a 10 from there, so that becomes 11. 11 take away 8 is 3. Because we've already exchanged or borrowed, we're left with 1 here. However, 1 take away 9 is impossible, so we'll need to exchange and borrow from the hundreds. So then we have 11. 11 take away 9 is 2. And in the hundreds column, we're left with 3. 3 take away 3 is 0, and then 5 take away 0 is 5. In a similar way, subtracting decimals. When subtracting decimals, it's very important that the decimal points are aligned correctly, so that the 9 is underneath the 2. and we would often put a placeholder, a 0, after the 2, and then so that it's easier to subtract, to think about that place there where we're subtracting 3 from 0, which will become 10 when we've exchanged. Multiplication, of course, one of the 4 main operations. Children need to know a language like product or multiples of 10, or factors of numbers. And we use the formal method of multiplication, and that's the short one, which children become quite confident with as long as they know their times tables. Now, knowledge of the times tables is a must. Children need to learn them by year 4, or if they haven't, it's paramount that they know them by year 6, and they're a life skill, so it's always handy to know them, and also to be able to apply multiplication in real life. And we do a lot of practice on word questions, which are often either on just multiplication or on various operations combined. 6 times 7 is 42, so I already mentioned the times table is very important because it helps with division as well. Now, if they were to multiply 725 times 6, they would use the column method, where they're multiplying 6 with each of the digits. 6 times 5 is 30, so they record a 0, they remember the 3, or record a small number to remind them. 6 times 2 is 12, they add the 3, which will make 15, they remember the 1, and then 6 times 7 is 42, and then add the 1 to it. Okay, there we are. 6 times 5, 30. 6 times 2 is 12. Add the 3, 5. 6 times 7, 42, and add the 1, so 4,350. Another question, similarly to the previous one, but this time there are 2 columns. So we start multiplying the 5, and we multiply the unit 5 with each of the digits of the top number. So 5 times 1 is 5, 5 times 0 is 0, 5 times 6 is 30. Then we need to record a 0, we call it 0 the hero, it's a placeholder, because the children are multiplying 4 by each of those digits, but actually they are multiplying by 40, hence the placeholder. 4 times 1 is 4, 4 times 0 is 0, 4 times 6 is 24, and then they add up the columns. 5 add 0 is 5, 0 add 4 is 4, 0 add 0 is 0, 3 add 4 is 7, and then 2. Okay, and if you would like to try 452 times 43, I'll leave you to record that and work it out in your own time. Division, again, children need to know language to do with division, and they need to know their times tables so that they can apply their knowledge of times tables with division. We use the so-called bus stop method when children are dividing by a single digit number, and long division when they're dividing by a 2-digit number, just so that it's easier for them to work out things that it might be tricky for them to work out in their heads. And obviously apply that with questions in real life, but I'm sure children use that and could be using that knowledge when you go shopping or when you do other activities, especially D&T ones. obviously, if they know that 3 times 4 is 12, it's very easy to work out that 12 divided by 3 is 4, because that's the inverse operation. Again, language that we associate with division. How do we divide 588 by 7? We use the bus stop method. Now we start with how many 7s go into 5. Because 7 doesn't go into 5, we put a 0. And then we move or carry the 5 so that we can make the number 58. How many 7s go into 58? That's 8. 8 times 7 is 56, which means that there are 2 left over from 58. And that's where we record the 2 left over, and we make a new number, 28. How many 7s go into 28? That's 4. This is the bus stop method, or short division also called. And I'll just talk you through this one. 6 doesn't go into 5, so 6 goes into 57 9 times. 9 times 6 is 54. This is why there is 3 left over. 32, 6 goes into 32 5 times. And because we have 2 left over, we could record the answer as 2/6, because 2 is the remainder and 6 we divide by, so that forms a fraction. Or the children can continue until they form a decimal number as an answer, which would be 95 1/3, which can be 2 and 2/6 can be cancelled down because they're both even numbers. Now we know that a third, 1 divided by 3, or a third, would be 3 recurring, so the answer would be 95.3 recurring. Yeah, and moving on, actually, if you would like to record this and try it by using the examples, 4,239 divided by 8, give it a try. And we're going to move on to fractions. Now we learn fractions and the 4 operations with fractions as well. And children need to have an understanding what a fraction represents. And then we move on to formal methods of adding, subtracting, multiplying and dividing fractions. Obviously, if the fractions do not have the same denominator, so they need to know that the numerator is the number at the top and the denominator is the number at the bottom, which the year sixes learn very quickly and easily. Then 2 and 4 are obviously different denominators, so we need to find the common denominator. In this particular case, it will be 4, because 2 goes into 4. And after that, when we know that the common denominator is 4, what we need to do is to convert a half into a fraction that has a denominator equivalent fraction, which is very important, that has a denominator of 4. So for that purpose, what I need to do is, if I'm multiplying the denominator by 2 in order to get 4, that means that I'll need to do the same to the numerator, meaning multiplying it by 2, which gives us 2/4. Now we can add the fractions because they have the same denominator, 2/4 and 3/4. 2 plus 3 is 5. That forms 5/4. Now, because this is an improper fraction or top-heavy fraction, or a fraction that actually needs to be simplified, what we do is, I always tell the children that actually this line is division and we are dividing. So what we're trying to find out is how many 4s go into 5. And that's 1. 4 goes into 5, and then we're left with 1, which becomes the numerator, and we keep the denominator the same. So the answer is 1 1/4. And in this case, 6 and 3, again, not the same denominator. The common denominator, the smallest common denominator, is 6, because 3 goes into 6. which means that we will need to be multiplying the second fraction 2/3 by 2, so both the top and the bottom number. So 5/6, if we multiply the second number, that will give us 4/6. And 5 take away 4 would be 1. How do we get 4/6? Once again, I multiplied both of the numbers, the denominator by 2 and the numerator by 2, hence 4/6. And our answer is 1/4. Sorry, 1/6. Okay, multiplication. I always tell the sixes that actually multiplication and division with fractions are easier than addition and subtraction. What we do is we record, and it's pretty easy. We multiply across. The two top numbers are multiplied, that's 12. The two denominators are multiplied as well, that gives us 55. So 12 over 55 is the answer. And how do we divide? With division, we would use the so-called KFC acronym so that they remember. So we say that we keep the first fraction 6/7, then F is for flip. We flip 1/3, and that becomes 3/1. And then we actually, instead of division, we'll use multiplication. C being we're multiplying, so 6/7 times 3/1. 6 times 3 would be 18. 7 times 1 will be 7, and then they will need to convert the fraction which is top heavy into a mixed number by dividing or finding how many times the denominator goes into the numerator. These are the key operations. Obviously, there is a lot more learning that we do in year 6, but it's very important that the year 6s have at least this knowledge as a minimum before leaving the year. Thank you.